All right, let's talk about rational equations. Yeah, I know, they can look super intimidating with all those fractions and variables hanging out in the denominator. But stick with me, because by the end of this, you're going to have a rock-solid strategy to tackle any of them. So first things first, let's change how we look at these things. They're not a chore, right? Think of them more like a puzzle, a math puzzle that's just waiting for you to crack it. Okay, let's just jump right into the deep end with an example. Take a look at this thing. Wow. I mean, you've got fractions all over the place, x's in the top and bottom, and, wait for it, a quadratic equation hiding out in that last denominator. It is a lot. And yeah, the question is staring us right in the face. Where in the world do you even start with something like this? Now look, if you've got a really simple case, just one fraction equals another fraction, you might remember that old trick, cross multiplication. And hey, for that, it works great. But when you're looking at a beast like the one we just saw with multiple pieces, yeah, that simple little tool, it's just not going to cut it. We need a bigger hammer. And that's where our master key comes in. Seriously, this is the one tool that will unlock any rational equation. I don't care how messy or complicated it looks on the surface. So what is this master key? It's the least common denominator, or the LCD. Now, the technical definition is right there. It's the smallest thing that all your denominators can divide into. But here's the real magic, the reason we call it the master key. The entire point of the LCD is to do one beautiful thing: get rid of the fractions completely. Just poof, gone. And finding it isn't some kind of dark art, it's a system, a simple process. First, you just factor every single denominator all the way down. Then, you look at all those factors and you make a list of all the unique ones. And finally, you just multiply them all together, making sure you take the highest power of each one. That's it. The thing you get at the end, that's your LCD. That's your key. All right, so we've got our key. Now it's time for the move. A simple, reliable method that I like to call the three-step takedown. And here it is, the whole game plan. Super simple. Step 1, you find that LCD we just talked about. Step 2, and this is the big one, the magic moment, you multiply the entire equation by the LCD. This is what makes the fractions disappear. And then step 3, you just solve whatever's left over, which is always going to be a much, much friendlier equation to deal with. Okay, enough talk. Let's actually put this takedown into action. We'll start with a nice clean example. X plus 8 over x equals 6. So step 1, find the LCD. Well, this is easy, right? There's only one denominator, x, so the LCD is just x. Now, for step 2, we multiply both sides of the whole equation by that x. And right here, you see the power of this whole thing. On the left, that x we're multiplying by just cancels out the x on the bottom. And poof! The fraction is gone. Just like that. All we're left with is a super simple, easy-to-handle equation, x plus 8 equals 6x. So much better, right? And now for the easy part, step 3, solve it. Just subtract x from both sides. You get 8 equals 5x. Divide by 5, and there's our answer. X equals 8 over 5. See? What looked kind of messy is solved in 3 clean steps. Okay, so you're feeling good, right? But hold on, it's not always quite that straightforward. There's a plot twist we have to talk about, a little trap. Sometimes the answer you get, even with perfect algebra, isn't a real answer at all. It's a phantom. This phantom has a name. It's called an extraneous solution. Basically, it's a solution that looks totally legit, your algebra worked out perfectly, but it's a fake. And it's a fake because it breaks the cardinal rule of math. You can never, ever, ever divide by 0. So an extraneous solution is any answer that when you plug it back into the original equation, makes one of those denominators turn into 0. So check this out. It's a perfect example. Let's say you go through all the steps, you do beautiful work, and your final answer is x equals 4. You're ready to celebrate. But then you glance back at the original problem, and you see that one of the denominators was x minus 4. Uh-oh. If you plug your answer, 4, into that denominator, you get 4 minus 4, which is 0. You just tried to divide by 0. That means even though all your algebra was perfect, x equals 4 is not a real solution. It's a phantom. It's extraneous. Which leads us to the one single golden rule you have to remember for these problems. Are you ready? Always check your answers. And you don't have to do a ton of work. Just take your final answer, plug it back into the original denominators, and make sure none of them
Not a single one becomes 0. If they're all good, you're golden.
Okay, so we've got the method, our three-step takedown. We know about the phantom solution trap to look out for. So where does this actually show up? Let's take a look at how this stuff applies in the real world, because believe me, this isn't just math for math's sake. These equations are everywhere.
All right, let's look at a classic word problem. You've got Jaime. She buys a whole case of concert t-shirts for $450. She keeps 2 for herself, can't blame her, and then sells all the rest for $560, making a neat profit of $10 on every shirt she sold. The puzzle is, how many t-shirts were in that case to begin with? Yep, you guessed it. This is a rational equation just dressed up as a story.
And this is how we break that story down into math. It's actually pretty logical. Let's say X is the number of shirts she started with, okay? The cost for each shirt, well, she spent $450 total, so that's $450 divided by X. The money she made on each shirt she made $560, but she sold X minus 2 shirts, so that's $560 divided by X minus 2. And the problem tells us the profit on each shirt was $10. And what's profit? It's just revenue minus cost. So there it is, our equation is 10 equals the revenue per shirt minus the cost per shirt. We literally just built the equation right out of the word problem.
So what happens if we unleash our three-step takedown on that equation? You find the LCD, you multiply everything out to kill the fractions, you solve the quadratic that's left, and you get your answer. It turns out there were 18 shirts in that case to begin with.
So here's the big takeaway from all of this. A rational equation might look like a total mass at first glance, but it's just a disguise. You now have the tools to handle it. You've got the master key, the LCD, and you've got the three-step takedown. It's a system for peeling away all that complexity to reveal the much simpler equation that's been hiding underneath all along. And that really leaves you with a cool question to think about, right? What other complex problems out there are just simple puzzles waiting for you to find the right key? Thanks for tuning in.